everyone, welcome back to Dragonfly Engineering. So this week we're continuing the dual shot molding project, which is going to replace this slow and Rube Goldberg dual robot, dual molding machine over molding project. So with the new rotating platen on the new molding machine, we can replace all this with just a single contained operation in the dual shot rotating table molding machine itself. So we're continuing from a few weeks or a few episodes of building this new mold set, and today we're going to build the second B side of the mold and insert some ejector springs and deal with some ejector pin clearance issues and other things. So hopefully you enjoy. All right, so we'll grab this second B side. Again, this is a dual shot rotating mold. So we basically have two duplicate B sides, which house the carrier plastic that spins from one location to the other. So we're essentially remaking, or not remaking, but duplicating the first mold that we made, but I'm going to show you various different steps. Okay, and for those who are just joining us, so this mold is set up with a pre-purchased mold base purchased from American Quality Molds. That's 7075 aluminum. And in that mold base, we drilled all of the ejector pin holes that pass through the main block of the mold on the B side of the mold, which is the non-injection side, where all the ejector plates and pins go. And then on all these holes, ejector pins pass through the hole and into the back of our mold inserts. This top plate is A2 tool steel, and it's 1/2 inch thick, precision ground. And then we machined these pockets to receive all of our mold cavity inserts, as well as we dowel pinned them and bolted this whole plate down. And the thought is that if we need to, we'll have an additional support block that's screwed in a keyed area on the side of the mold that will help reinforce this end of the steel reference plate for our mold cores. Because it's possible with the high pressure of the molten plastic squirting into the runner and the cavity that all of these inserts may want to push against this strap of steel. So we want to reinforce that as much as we can. So with that being said, I will start to load our inserts, and I've already figured out the orientation or the arrangement, basically matching the low sides. We're gonna effectively balance out all the low sides and distribute them as well. Like for instance, this block says -3, so this is -3 microns in height from the ideal 1/2 inch or 12.7 millimeters. So we're just gonna distribute the deviations in the heights across the mold to balance them all out. And then when the molding machine closes on this the first time, it will probably press into the aluminum a few microns to fix any of the final deviations, or kind of seat everything, kind of the first clamp up. So I will start to load these parts in. So we'll do -3 here, and then we got like a -2 that we'll put over there. So, and I'm gonna line up the runner with the pre-machined runner in the base frame, or the reference frame. So we'll do a final check on cleanliness, and we can drop this guy in. You kind of have to wiggle precision parts in. If you just try to just drop it in, usually it just hangs up because micro angle defects, or not defects, but you got to get precision parts to be exactly parallel. So the best way to do that is to kind of wiggle them and drop them in. So like this one dropped in, and we'll just kick it to the corner and start screwing these guys in. The last one's always the hardest. So I think it's easier to get the top and bottom sides started into the hole, and then kind of tap it and slide this block forward, keeping the angle on the small side. And I'm tapping on this top corner to try to keep the thing parallel and then get this edge to contact the cavity hole edge, and then just have it sort of just seat down in, trying to remain parallel. That sounded good. It felt like this edge dropped in, so I think we are parallel and we can drop down inside. And we'll just roll around a little bit, and it's, again, you know, parallel edges can jam up real easy, so you just go slow and you keep walking around and you're tick-tocking the jam, the part jamming up in its pocket. You just keep resetting it as you go around. And then when you get about halfway in, it should just drop, because it's kind of locked in parallel and it can't roll out of square easily anymore. So you just drop it in like that. And there you go. Just check tightness on all of these. It also helps to keep these a little loose, you know, to scooch a few microns here and there to get the final block in, and then we can just tighten them all. We don't want to over tighten. These screws kind of just keep the blocks from getting pulled out if a part is kind of stuck on this cavity that we're going to burn in. Then, you know, these screws keep the block in place and the part pulls off the cavity, as opposed to the part pulling the block with it, which unfortunately I've done before. Okay, that's it. So now what we're going to do is basically build up this mold half the same way that we did last week on the first of the 2 rotary B-sides. So we'll probably just time lapse all of that, actually. So enjoy the time lapse. So let's switch into hyperdrive and assemble this second mold set that accompanies the first mold set we did last week. So start. Okay, so we test fit everything in the mold to make sure that all the pins were right. I actually had to flip a couple of pins around because they were pre-shortened for some of the runners. And now what we need to do is add our spring returns, or return springs for our ejector plate. Whoops. So here's one of the die springs that we will use. And they're color coded and everything, and they're really stiff, which you need for returning an ejector plate in a molding machine. The molding machine probably wouldn't even notice a spring like this, but I can hardly compress it at all. And so in this architecture, since we're rotating the platen, we can't really have push and pull rods that connect to the molding machine, so we need to bump this plate forward to eject the parts off of the the B side out of the cavities. But then when the molding machine pulls back its ram, we need springs integrated into the mold itself to retract the ejector plate and all of the ejector pins back to the home position, which was basically defined by the bottom of the travel of the mold. You know, the gap created by our riser right here. So, and you kind of have to make sure everything's together before you put the ejector springs in, because basically you can't move the plate manually like with your own hand force once these 4 springs are inserted. And to insert these, we just push one of the return pins back one at a time. And actually I'm going to pull the rest of this plate back It can be a little tight. In fact, I think there was one pin in here that still isn't happy. I think it's this one right here. So I may pull this one out and figure out what's up with that one a little bit later. But yeah, so what we need to do is push all of these pins back and the plate itself. So I may need a little persuasion to do that, aka the rubber mallet. So I'm going to push down at the bottom, opposite corner with my hand, and then knock this plate back. There we go. You know, when you've got like 3 dozen, or like, I don't even know how many pins are in here, 40 pins, each pin has a little resistance, but you add up 40 of them and resistance can increase notably. Okay, so we need to get our ejector plate back far enough so that we can slip a spring in one pin at a time, just like this. So there's our first spring, and we just go around and put one spring in each return pin slot, and these springs basically just ride on the return pins and keep aligned. So now our ejector plate is about ½ an inch farther back than where it's going to be when the back of the mold goes back on the back plate and the riser blocks. And what we are going to do is use our 1/2-13 bolts to bridge the gap that is, oh, actually I got to put the back plate on first. Let me stick this back plate back on so that our return pins and ejector pins are captured correctly. And now we will reapply the bottom of the mold, which is the 2 risers and the back plate. And I will slip this back over, and hopefully we can engage the 1/2-13 bolts, these guys. And it looks like it will span the natural relaxed spring length so that we can use these bolts to effectively clamp our springs into final tension. So, you know, you want, after your ejector plate pulls back to the final position, you still want these springs to be pushing to hold your ejector plate in the back position so that the next shot you don't have issues with the pins sticking out a little bit. Granted, the pins will, as a redundant safety, will be pushed back by the return pins themselves, you know, these pins that go through the entire mold. But it's best to not have a sloppy mold action. So these springs still need to be preloaded when the plate goes all the way back. So we've got an extra ½ an inch of gap here, which I think is approximately 50 pounds of force per spring. So there's going to be about 200 pounds of force holding this plate, this ejector plate back in the back position as the molding machine is ready to close on the next shot. So, and what we're going to do is use our bolts here to compress our return springs to the final compression as we close up our mold and tighten it up. That way we've got pre-tensioned ejector plate in the back. But this only works if your bolts will actually reach the threads in the base of your mold itself. If not, then you either need to try to hold it, push it together, which is not practical, or get like a big C-clamp or bar clamp or something to clamp your springs enough so that you can start your bolts to bolt your mold back together. I'm also checking the ejector pins themselves to make sure I don't see any of them buckling, because we did pull some of these pins out of the final reamed section of the mold, which is basically just on this plate. So I am hearing some popping sounds, which I just need to make sure that I don't see any pins that are out of line. We can also watch from the front too, but let's just hope for the best here. I'm not a big fan of hearing popping sounds when I'm assembling a mold. Oh, I see some that have a problem right there. Yeah, I got a couple of pins that have some issues. Let's see what we can do to solve that. I've got a couple of pins that did buckle because they're not back in their reamed position. They're still in the rough hole. The tip of the pin isn't aligned correctly, and normally you got to jiggle it into place to get it seated into the reamed portion of the hole, but our plate is too far back. So I think I will replace the 2 pins that buckled. Maybe I can zoom in on it. And I'm gonna have to clamp our mold shut to get all the pins happy. Yeah. Yeah, so these 2 ejector pins buckled over a little bit. So those couldn't find their proper home in the reamed hole. All right, so I've thought about it a little bit, and yeah, the issue is that the precision part of the ream is about the same distance as the preload on a spring. So to clamp our spring shut, our ejector pin tip is right at the beginning of the preload, or is right at the beginning of its reamed hole, which has probably like a little, well, I know there's a little a taper in there, and a couple of the pins, these 2 in particular, don't seem to want to find the funnel shape to get into the final reamed hole. You know, it's getting caught up somewhere, and it would rather buckle than go home. All right, so I've got a new plan here. I took one of the backs, or I took one of these inserts out and looked at the back, and I did not chamfer the bottom holes for this set of inserts, unfortunately. So by not having a little guiding funnel on the back of these inserts, when the ejector pin pokes through the clearance hole on the back of the aluminum block, it just finds a sharp corner on this block and doesn't go any further. So what I'm doing now is I got a 30-degree hole chamfer tool here. So it's a sharper, you know, a better lead in than a 45-degree. And I'm going in here and I am adding a lead-in chamfer or funnel that will guide our ejector pin to the proper location. And I think what I'm going to do is, so I'm going to add the funnel to all of these inserts, which means I got to take all these inserts back out. And my thought is, instead of messing around with C-clamps and stuff, I may actually preload the springs and have our ejector pins poking through and beyond where the final inserts are going to be. So the thought is that I can string the mold insert through all of the ejector pins while the plate is in the back position, and then reattach them with the pins forward, and then release the plate back. That may not work out, and it may not be a good proof that, you know, like a year from now when I service this mold and I pull this back ejector plate off and pull the pins back, I would like all the pins to go back into the hole that they need to go in, because a year from now I may forget this if I don't write notes about how this was assembled. So I will maybe try both, but perhaps I should go with the traditional way of rebuilding the mold so I don't create a little trap for myself a year from now. So anyway, I'll pull all these off and chamfer this and then stone the bottom, because whenever you chamfer these kind of details, you can feel a little bit of a burr. There may be a burr inside where the ream is too, so it's possible I'll push out, or I'll push a ejector pin through all of these to make sure that there's no little burr inside of the bottom of the cones I'm adding. I'll try whacking this from the back to pop some of these mold cores out. You got to get one started. Looks like we're not there yet. Come on. There we go. So here is a before chamfer and then after chamfer, and I'm gonna have to deburr or stone off that little burr that was created. Okay, with our diamond tool, I will smooth out our chamfers, and then you can see the little diamond swirl there. So yeah, that little diamond sure does cut metal. Now we don't have to fuss with those C-clamps or bar clamps or anything. Because, yeah, I need to get this mold on the EDM machine because the EDM process can take a while. So time is of the essence, always. Yeah, it does feel a lot easier, so I'm not bottoming out a bunch of ejector pins anymore, so that's good. I didn't want to over chamfer the bottom of these blocks because I want to maximize the amount of precision reamed hole that the ejector pins are guided in. And you don't want to skimp on the preload on your springs either. So effectively, the ejector pins are only going to travel probably another 2 to 3 millimeters beyond this 13 millimeter thick top plate. So yeah, it's not very much travel. All right, so our springs are compressing as we finish out our clamp or our preloading of the ejector plate. And we should see some pins sticking out the front. And all of this wasn't an issue when I assembled the first mold because these springs weren't in there yet. So I just basically pushed all the pins forward and then pulled them back and didn't have to go beyond the travel of this plate. But when the springs are involved, we did go beyond the travel of that plate, which caused all of our little issues. So I'll have to go back and probably chamfer the back of all of these inserts on the other mold too and keep track of which insert goes where at that point. Okay, so when we look around at the front, you can see all of our ejector pins are extended, or not extended, but they're in the retract position, but they're sticking up beyond the base of the pocket that our inserts go into. So let's see if we can string all of our inserts on now. This may be tricky in and of itself. I guess we can start with this one. This may actually be easier, you never know. I probably do need to tap these in. There we go. I think I'll have the So I've shown you all the ways of inserting inserts into a mold. There we go. Again, getting those pins to start into their chamfered holes correctly. We may be knocking out some micro burrs, which will be followed up by the EDM process. Okay. And we'll go with this one for this corner. All right. Yeah, all these ejector pins are actually nice guidance pins. And then when we tap it with a hammer, the little mechanical shock waves that are going through the block and the mold will instantaneously release little jam spots and kind of vibrate and reseat the orientation. So you can hear it sometimes if it's finding its home or not. This one's going to be a little trickier, I think. There, like that sound was a good sound. Okay, there we go. Let me retighten all these screws down, and then we are, I think, ready. So on the previous setup, I actually clamped the mold base down to the table of the EDM machine and had a strap clamp push the plate down to the bottom since these springs weren't in there. Now, well, I'll probably still clamp right here, but these springs being in here is closer to the final architecture, which is better for, you know, when you do your EDM work, so that you know that these pins are going to be in the right spot. So we'll lower the tank door down, which normally houses all the EDM oil. So this is the first mold half that we EDM'd in the previous episode. So we cut all these cavities in here. Yeah, so these are all the cavities that were burned in using this graphite electrode right here. So we can pull out the old, or the first mold, and we will get our second copy loaded up in there. And this ground is what closes the circuit between the electrode that's electric discharge milling the metal and to the ground of the power supply that creates the very complicated AC current that actually creates the sparks that eats away this steel. So without this ground, you're not going to get any spark. It's been sitting there clamped for a while. There's an oil film that's created a vacuum. And I don't want to slide it because I don't want to abrade and mess up the surface of the EDM machine. So I'll just pull and try to break that vacuum. There it goes. And then we can lift off. All right, so this came off the EDM machine. We're going to put this one on, and it's pretty much the same process. And these molds will rotate in the dual shot molding machine on the rotary platen, so that this side that gets the polypropylene squirted onto it flips over to this side, and then rubber will be over molded onto the polypropylene that's stuck in the cavities. And then this side will be over here and we'll get its polypropylene. So they basically just keep circling continually. It's actually more like this and then like that. So anyway, let's get this guy on next.